This is the laser telegraph, and here is the message I'm typing in. Morse code only has A through Z and 0 through 9. So there's my message, and I start it. And you can see it on the screen, typing out the dits and das, and you can see the corresponding laser flashing on and off. I don't have the laser pointed directly into the camera for obvious reasons. But yes, that is the laser telegraph operating. So this is one way to receive it, to see the beam. Obviously, it's not recommended to spend long times looking at laser beams. Another way to receive the beam is just to look at it as it reflects off of an object, and here, in this case, my finger, but a wall would work. You can shine the beam through a window, and somebody can just look on their wall to see it flashing on and off. If you want to make your laser harder to detect the source and receiver of it, you can shine your laser down a tube. You can put your laser inside of a tube, because as you can see, only when you're looking straight down the tube can you see where it's coming from. And obviously, the longer the tube, the better, but this will help shield the laser from prying eyes. Let's try another experiment. Here I've got this is made by Snap Circuits. This is just a light-sensitive circuit, and if you prefer, you can make you can hear that? So it's converting the light into sound if you'd prefer that. This certainly is not a laser communicator, but still might be interesting. If you're on a ship and you want to signal another ship in Morse code, or if you just don't care that somebody else sees your transmission in the open, this is certainly bright enough to get the message across. This is the code that runs our Morse code laser transmitter telegraph, and a little more complex than before, but not too bad. These are comments up here, just tells what I'm doing. I connected the positive on the laser to pin 7, I grounded it to pin 6. I used a 100 ohm resistor on the laser just to make sure I didn't overdraw the pi. It does dim down the laser a bit. I'm not exactly sure what the specs on the laser and the pi are. I don't want to overdraw my pi, so I put it on there for safety. GPIO library import, time import, so I can use the sleep function. Sys import, so I can use a system exit. It's a nice way to end the program rather than just letting it crash if something goes wrong. This is the Morse code. It's online. You can find it under the, what do they call it, the domain, the commons, and can copy that and copy and paste and put it in your program and format it however you want. This is the setting the board pins on the board. This is setting pin 7 as output. And here I have a lot of stuff right here for timing, if you will. So this is timing on the between dots and dashes. And I can change this and then change pretty much everything here because it's all based on this didod delay. My dot is equal to didod delay times 2. The dash is equal to didod delay times 10, so a ratio of 5 to 1. My letter delay, that's delay between letters, is 4 times the didod delay, and word delay is 8 times the didod delay. So that's delay between words, and this is delay between letters. Here is a function just to check the string, because Morse code does not include all the ASCII characters. There's no equal sign, there's no ampersand, there's nothing. It's A through Z and 0 through 9, and that's pretty much it. So what this does is it goes through the string and just checks to make sure it's in that list we have up here. If not, it'll print an error message, tell us which character was wrong, and then it'll do a nice exit. This is the function that does the dots and dashes, and I ask for the channel and I ask for the amount of time, so whether it's a dot or a dash, it's the amount of time that the laser is turned on. And so here pin 7 gets turned on. If it's a dot or a dash, it turns it on for that period of time. Down here it turns it back off, and then it waits the time between the dots and dashes. The next function is our main function, and the first thing we do is we ask for the message that the person wants to send, and we remind them that it's A through Z, 0 through 9 only. We call the check string function, and we pass it this value, this Morse code transmit. So we pass it that, it'll check it. Then we go off into actually the business of sending the message. So we look through all the characters in the Morse code transmit string, and if the character is a space, which means probably between words, we print 4 spaces, so this makes it visually nice on the screen. And then we definitely set the laser to false because we don't want the laser turned on for any reason during this time. And then we sleep, and this is the word delay, so this is delay between words. If it's not a space, then it's a letter, and so we go look at this list of Morse characters, and we run this loop, and the loop we're looking for the dits and the das inside of our character. So if it's R, it's like dit da dit. So if there's an R in here, then we'll have a dit da dit. And the first thing it will do is it will look to see if it's a dash. If it's not a dash, I assume it's a dot. If it is a dash, it'll go call the dot dash program, the function, and we'll pass it the 7, and we'll pass the dash value, so the longer laser on time. If it's a dot, we'll pass it pin 7, and we'll turn on the dot time, which of course is much shorter. And then of course we'll delay between the letters, and that's what the letter delay is. This starts the main program, and at the end, when it's all done running through the message and pumping it out through the laser and printing it out on the screen, we'll do a GPIO cleanup to reset the pi back to its original condition. We'll print a blank line and then print done just to make sure it all looks nice. So that's it. Well, I hope you found it interesting and useful in your pi experiments.